Review Chapter 7 on Similarity. We had 5 sections in this chapter, and we're going to start with 7.1, which was ratios and proportions. So our first problem says the average length of 2 species of rattlesnake are given. What is the ratio of the pygmy rattlesnake to the length of the western diamondback rattlesnake? So we are told what order it needs to go in. And the pygmy rattlesnake's average length is 18 inches. The western diamondback is 5 feet 6 inches. That's a pretty big snake. And so I want them to be in the same units. I could either change inches to feet or feet to inches. It's frequently easier to take the big measurement and go smaller. 5 times 12 is 60 inches. 60 plus 6 makes this 66 inches long. I put 18 to 66 and I reduce. What'll go into both of those? 6? Let's try that. 18 divided by 6 is 3 to 11 inch ratio. 3 to 11 ratio of the, not how you spell pygmy, of the pygmy rattlesnake to the western diamondback. We could also write that as a 3 to 11 inch ratio, pygmy to western diamondback. Yay, that was fun. Our next problem says solve each proportion. These are easy. We just cross multiply. We get 4 times x equals 9 times 16. So 4x equals, what is that? 144? That sounds about right. Divided by 4, x equals 36. And the next one, cross multiply. Oh, this one's got a little more to it. 4 times x equals 12 times, don't forget your parentheses here because that's a single idea, 2x minus 5. That means we are going to have to distribute. So 4x equals 24x minus 60. I'm going to subtract 24x from both sides, and I get a negative, don't lose those negatives, a negative 20x equals a negative 60. Divide by negative 20 on both sides, and x equals 3. Woo! Proportions are easy to solve. Next problem says the measures of 2 complementary angles are in the ratio of 7 to 11. So what does complementary mean? And ratio. What does complementary mean? That's right. Complementary. And I know that one of them, it's a 7 to 11 ratio, so we know we need a multiplier on those. And so 7x plus 11x equals 90. That's what complementary means. So 18x equals 90. Divide by 18. X is going to be, let's see, that's a 10 to 2. So x is 5. So I'm asked what's the measure of the smaller angle. So that would be 7x would be smaller than 11x. 7 times 5 is 35 degrees. And I just can't help myself to find the other angle is 55 degrees. And if I write those in here, this one's 35 degrees, 55 degrees. We've got a 90-degree angle. Yay! So 7.1 was fun and easy. 7.2 was on similar polygons. So what did we do here? We are told that triangle QRS is similar to triangle DEF. And if we wanted to, we could draw them out and mark all of our corresponding angles and corresponding sides. But we don't need to. I mean, you can. You know how much I enjoy drawing and labeling. But we know that position 1, matches up with position 1, and position 2 matches up with position 2, and position 3 matches up with position 3. So what are the pairs of congruent angles? Well, angle Q is congruent to angle D, because we know in similar polygons that all corresponding angles are congruent and all corresponding sides are proportional. So Q and D and angle R is congruent to angle E, and angle S is congruent to angle F. I just followed my nice little colors there. And what's next? What is the extended proportion for the ratio of the corresponding side lengths? Easy, easy. I just start at the beginning, and I know that QR compares to DE, which equals to, because they're proportional, RS, which equals EF, or which compares to EF, which is equal to, and we'll go back around this time, SQ, 3 to 1, compares to 3 to 1 is F to D. So there's our congruent angles and our proportional sides. And let's use those skills in the next problem. We are told that triangle NOP is similar to triangle WXY. Find each of the following. Well, this time I am going to use my colors NO and WX and OP and XY and P back to N and Y back to W. Okay, so there are my corresponding sides. I know those are going to be proportional, and my angles are going to be congruent. So I am going to go in and write in some angles, because I know angle N is the same as angle W. So look at that. I know N's 49, so I'm going to go in here in W, and I can make that 49 degrees. And I know that angle O is the same as angle X. Well, I know angle O is 58, so angle X has to be 58 degrees. And I know P and Y are the same. I don't know either one of those. But you know what? Bet we can find it. So the measure of angle P plus 49 plus 58, triangle angle sum theorem here, says they equal 180. That's 50, 107. So minus 107 on both sides. The measure of angle P is going to be 73 degrees. So I can go in, and I know that this is 73 degrees, and I know this is 73 degrees. All right. So we have labeled everything we know. Let's start doing some work here. We need a scale factor. Well, I need two corresponding sides. I don't have both purples, I don't have both blues, but I do have both greens here. So we are going to call this figure 1, this figure 2, just so I can keep them in order. And I have a scale factor of 4 to 10, which is 2 to 5. So my scale is 2 to 5. That could come in handy. And the measure of angle x, well, let's see, we worked that one out. Measure of angle x is 58 degrees because it was congruent to measure of angle O. And what's next? Measure of angle y is over here. That's 73 degrees because we use triangle angle sum to find that. And the length of WX, well, that's my purple side. How am I going to find my purple side? Well, luckily, I know my green side. So I know that 2 to 5 equals, I can write a proportion for purple side, 6 to WX. So I get 2 times the length of WX equals 30. Divide by 2 on both sides. The length of WX is 15. So WX, length of WX is 15 units here. And the last one, NP, that's our blue side. How are we going to find our blue side? Oh, I want to go right in. This is 15. The same way. I could use my newfound purple sides to write a proportion, but I don't have to because we already have a scale factor. And so my blue sides, NP is to 12 on the second one. So I just cross multiply. 5 times the length of NP is 24. Divide both sides by 5. And the length of NP is, that's 4 and 4/5 is 0.8 units long. So I can come over here, 4.8. Now, does that seem reasonable? I've got a 4, 4.86 triangle and a 10, 12, 15. That seems like it could be reasonable. They changed about the same rate. All right, that was fun. Moving on to 7.3. We were proving triangles similar. So what did we use here? We had our angle-angle similarity postulate, our side-angle-side similarity theorem, and our side-side-side similarity theorem. Remember, angles are congruent, sides are proportional. So let's look at the first one here. Are our triangles similar? If so, write a similarity statement and justify your reasoning. You know how much I like it when you justify your reasoning. Well, what do you see here on this first one? I see parallel lines, which makes me immediately think of special angle pairs, which corresponding angles there, corresponding angles there. So we could use the angle-angle similarity postulate. And notice also we've got another one up here. 1, 2, 3. We could have used that one. We could have used reflexive property and corresponding angles. We've got angles all over the place on this one. So let's write a similarity statement. I'm going to start with my big triangle. I'm going to go green to common angle to blue. So MN, is that an L? L is similar to triangle. Start on green, PNO. Yay! All right, let's do the next one. First thing I see here, we've got one angle, and here's a side. That's my big side, so I'm going to big side and small side and small side. Ooh, do we have side angle side? We can't say yet. Our angles are congruent, but do we have proportional sides? Well, let's start here. We've got 12 to 16. Divide by 4, so that's a 3 to 4. and blue sides are 15 to 24. Nothing, 3, divide that by 3, 5 to 8. Aw. So, no, my sides are not proportional. So it looked like they could be similar. They were not. All right, next one here. Oh, are these triangles similar? Well, don't mix these up with our side splitter theorem. There is no parallel line. So the first thing I'm going to do is redraw my two triangles. And this is, we'll make this one the big one, MC. Let's make this one the small one. QCT and MCP. All right, so we've got a reflexive angle there. That's always a good start, right? They've got a common angle. And how long is CQ? That's 12. And how long is CT? 21. And how long is CM? 12 plus 8, that's 20. And how long is CP? 21 plus 14, 35. So we've got an angle, now we need sides. So let's check our sides. I like to call this one 1, this one 2. And I'm going to do 12 to 20, 4, 3 to 5, and 21 to 35. It's a 7. 7 goes in there. 3 to 5. Woohoo! They're proportional. So we have side angle side similarity theorem and triangle. I'm going to start here on the left. QCT is similar to triangle MCP. Yay! And our last one, no angles, but I see a whole bunch of sides. First thing I'm going to do here is flip my little triangle over so that Q is on top. And if I spin it around, P is here, O is here. You could just flip it over if you want. Doesn't matter as long as everything's in the right spot. So 15 is now on the bottom and 13 is on each side. So let's match up some sides here. We're going to go blue, blue, green, green, and purple, purple. Those look like how our sides are going to match, aren't they? So let's start with blue. 26 to 13. That's a 2 to 1 ratio. Looking good so far because green is 26 to 13. That's a 2 to 1 ratio. And purple, oh, looks like we have a winner here. 30 to 15 is a 2 to 1 ratio. So, yay! We've got the side similarity theorem. And this is going to be easy to write the triangle congruence. I'm going to go up blue, down green. Is similar to, I go up blue, so that's P to Q, down green goes to O. So that was fun. Don't be fooled by the ones that look like they should be similar. You have to check the proportionality of your sides. And on these others, split them up, separate them, redraw them, label them. Color is your friend here. And the last problem in this section, A 1.6 meter tall woman stands next to the Eiffel Tower. She's casting a shadow 0.5 meters long. Tower's shadow is 93.75 meters long, 75 meters long. That's a long shadow. How tall is the Eiffel Tower? Pretty tall, I'm guessing, because that's a really long shadow. So we're going to draw some pictures. Here's our woman. Yay. And it says she is 1.6 meters tall, and she casts a shadow that is 0.5 meters long. We have a nice little right triangle here. And the Eiffel Tower, I don't know how to draw an Eiffel. That's pretty good. There's an Eiffel Tower. It has a nice right triangle here. We know that it casts a shadow that is 93.75 meters long, and we want to know how tall is the Eiffel Tower. These are similar triangles. Because the sun is shining down and casting a shadow, we'll have a congruent angle up here. Similar triangles, and we can write a proportion. So we compare 1.6 is to x as 0.5 is to 93.75. So 0.5x equals, oh, that's convenient, 150. Math is fun. Divide by 0.5 on both sides. That's just like multiplying by 2. So x equals 300 meters tall. Eiffel Tower's pretty big. All right, 7.4. We're almost done here. Similarity in right triangles. These were formulas. Remember, we had formulas. So the first thing I'm going to do, leg 1, segment 1, altitude. Leg 2, segment 2, and this entire thing here is my hypotenuse, which is 5 plus 4 is 9 units long, right? 5 plus 4 gives me the whole thing. Now I'm going to start working. Find the value of each variable. Write it in simplest radical form as necessary. So the reason we can do this is we've got a right triangle with the altitude to the hypotenuse. That means it goes from the right angle to the hypotenuse, so we can use our formulas. So x here is leg 2, so what's our leg formula? It says the hypotenuse, and your leg is your geometric mean, and it's compared to the segment that is adjacent to the leg. So I can just write an equation. Our hypotenuse is 9 over x equals x over 4. X squared is 36. Square root. Take the positive because it's length. X is 6. So we know that side is 6. Next, y. Y is our altitude. We know that the altitude is the geometric mean, right? Altitude is the geometric mean of the segments of the hypotenuse. So that gives us 5 is to y as y is to 4. So y squared equals 20. And we square root. And y is the square root of 20, so we need to take the square root of 20 and factor out perfect squares. Perfect squares, 4, 9, right? What are our perfect squares? 4, 9, 16, 25, 36, 49, etc., etc., etc. 4. 4 goes into 20. So square root of 4 times the square root of 5. 5 has no perfect squares in it, so y equals square root of, erase this here. Square root of 4 is 2 times square root of 5 because it's not perfect. So y equals 2 square root 5. 2 square root 5. Just a number, don't be afraid of those square roots. And z. Oh, z is another leg. So it's our leg formula again. Hypotenuse over, this time it's leg 1. Leg 1 is our geometric mean over the segment adjacent to that, so segment 1. So then I just start putting in numbers. 9 over z equals z over 5. So z squared equals 45 square root. Z equals the square root of 45. Look at what we multiplied. This is a little hint on these. We're going to factor, we're going to simplify our radical here. Look at what we multiplied to get 45. 9 times 5. 9's a perfect square. So it's going to come back out. 9 times the square root of 5. What's square root of 9? 3 times the square root of 5. So z equals 3 root 5. Yay! And our last set of problems here. These were our special proportions in triangles. Find the value of x, justify your reasoning. Alrighty. I see parallel lines. That means that I immediately know that this and this are proportional, and this are proportional. So I just make 4 square and write whichever proportion that I really seem to like. I am going to use 12 to 14 equals 9 to x. Cross multiply. 12x equals 9 times 14, 126 divided by 12. So x equals 10.5. And this is the side splitter theorem. Sounds like a monster truck name. Side splitter theorem. All right, next on our list. Ooh. And the corollary to the side splitter theorem. So once again, we've just got a 4 square here, but we need to know this length on top. On the right hand side over here, we know the entire thing is 35 and this little piece is x. So we're going to call this piece 35 minus x. It's just our segment addition postulate backwards. Right? These two pieces together make 35. 35 minus x plus x is just 35. So I have my 4 square here, and I'm just going to write it top to bottom, which makes me happy. 20 to 8 equals 35 minus x to x. Cross multiply. 20x equals 8 times, don't forget those parentheses, 35 minus x. 20x equals, what's 8 times 35? 280 minus 8x, add 8x to both sides, and we get 28x equals 280 divided by 28, running out of room. X equals 10. Yay! And our last one here. Do you see it? I see it. It's the triangle angle bisector theorem. I see this ray right here that bisects the angle, which means those end up proportional to those. So I'm just going to write myself a happy little, we've got a 4 square. I'm going to write myself a happy little proportion and do the problem. X over 13 equals 9 over 10. And cross multiply, 10x equals 117. Divide both sides by 10. X equals 11.7. That seems pretty reasonable. 9 to 10 and 11.7 to 13. Yeah, that seems pretty reasonable. What would these be over here? This would be 10 to 25, 8 to 20. That seems pretty reasonable. And our first one, we got 12 to 14 and 9 to 10.5. Yeah, those all seem pretty reasonable. All right, so chapter 7 is not really bad. Just be careful when you write your proportions. Use your color to help you out. In similar figures, angles are congruent, but sides have to be proportional, and that means that all of the ratios have to be the same, and we call that the scale factor. Scale factor is used to write your proportions, lets you find your unknown sides. And then right triangles, if you have an altitude to the hypotenuse, you get all kinds of special things happening, but those are just formulas. You've got these 3 formulas here. They're just formulas. You write them down, you label your triangle, substitute in. And then 7.5, we had our 2.5, because one's a corollary, special situations that deserve their own theorem. When requirements are met, you know that things are proportional. Are parallel lines or an angle bisector. I really believe that you are going to do awesome on this test as long as you are careful. Use your color. Draw and label, and you will do fine.